section 1.5 is on measuring segments. Remember that we can't measure lines or rays, but we can measure segments. And there are different ways that we have of measuring segments and of showing how we measure segments. One of the first things that you're going to have to know is a word called the midpoint. It's a point that divides a segment into two congruent smaller segments. So, for example, if this is my segment, if I find the point directly in the middle of this segment, I'm going to name it point M because it's a point, so I name it with a capital letter, but I would say M, if it's directly in the center, is the midpoint of this segment. Okay? So let's say that this is A and this is point B. These are the endpoints. M is the midpoint. That means that the segment from A to M would be exactly the same measurement as the segment from M to B. We would call those congruent segments. It simply means that they have the same length. There's a symbol for congruent. The symbol is the equal sign with the little, looks like the Spanish tilde over the top of it. Those two pieces, those two symbols put together mean congruent. It means they're the same size and the same shape. So it's two segments that are exactly the same length. We would write that by saying AM, and we would put the segment symbol over the top, and MB with the segment symbol over the top, and then we would put the congruent symbol in between them. Okay, that means that this segment is congruent to this segment. They're the same size and shape. Another way to show congruent would be, for example, in this picture, I can show that they're congruent by making something called tick marks. Okay, a tick mark is simply a little line that you would draw on the two segments, just two little lines, and those two little lines mean that whatever this little line crosses is the same as whatever this little line crosses. So tick marks also show that pieces are congruent just in the picture itself. This would be writing it in sentence form. This would be using it in a diagram. Okay? Both of them mean exactly the same thing. If you have more than one pair of segments that is congruent in a picture, you can use more than one tick mark. Okay? So let's say you had a rectangle, and we would use one set of tick marks here to say that those two sides are congruent, but we would use a different set of tick marks for these two because they are also congruent. So I would use two tick marks to show that this one's congruent to this one and this one's congruent to this one. The ones that match are the ones that are congruent. When we talk about the length of segment, I said we could measure segments, and we can. We have something called the ruler postulate that says that you can measure something that starts and stops. Notice that I wrote AB as a segment. Okay, AB is the segment, but notice I don't have any symbol over the top of it. Okay, when I put the symbol over the top of it, when I talk about AB like this, that is the segment. Okay, when I put AB with nothing over the top of it, that means we're talking about the length. So when I talk about this, I'm talking about the actual object. When I talk about this, I'm simply talking about the length of that object. So I would say that the length of A to B is 7, meaning that AB is 7 units long. When I talk about segment AB, I'm talking about the line segment itself. Okay, so there's a big difference. When we talk about segments, we talk about, and they're the same length, we would say that they're congruent. But when we're talking about lengths, then we're talking about numbers, and in that case, we'd only use the equal sign. Okay? So I know that congruent and equals easily get confused, okay? And through this first section, we're going to talk a lot about when to use congruent and when to use equals. But here are 4 quick examples that you can look at, okay? Notice it says AB and there's no segment symbol over the top, and 7 is on the other side. So when we talk about AB equaling a number, then equals is what we use. Here we have a segment PQ and a segment MN. The segments are a little off center, but when we talk about one segment and another segment, then we're talking about the objects themselves. So in that case, we would use congruent. Okay. Here I'm talking about the length from Y to Z and the length from F to G. So here we're talking about lengths. So then we would use equals. Here I'm using the segment symbol. I'm talking about the segment itself, but I have a little m sitting in front of it. That little m stands for the measure. So the measure of segment CD and 10, so that's also an equals. So only when you're talking about the segments themselves do you use congruence. Every other time when you're talking about lengths, you always use equals. This is something to highlight in your notes. It's something you may want to star, highlight, make a mark, big mark next to something. Segment addition postulate is one of those things that we will use starting now from the time you learn it until the end of the year. Segment addition will continually pop up. So this is one of those things you really want to pay attention to. Okay? So the segment addition postulate simply says that if you have a segment, for example, it has points A, B, and C labeled on it, that it's actually two smaller segments, AB and BC, and when you put them together, they make AC. Now, I know that sounds kind of silly, that obviously AB plus BC equals AC. But for some reason, that seems to be something that kids struggle with. So when we talk about segments, okay, we talk about, for example, if the distance from A to B is 7 and the distance from B to C is 4, and I asked you, how long is AC? Most of you could say, well, AC is 11. That's because you add 7 and 4. And that's great when we talk about simple numbers like this. But when we start talking about algebra, and I want you to find missing values, this goes out the window. Okay, we know that 7 plus 4 equals 11. That we know. But when you come down here and look at it this way, okay, and say, well, now AB is x, and BC is 3x plus 1. Well, what did I do with AB and BC in this picture? Well, I added them together. So what am I going to do with AB and BC in this picture? Well, I'm still going to add them together. And then they equal, we added them together to get 11. Well, they tell us that the total from A to C is 25. So they tell us that the total there is 25. So now we're using segment addition still, but our problem looks a little bit different, and kids have a hard time going from using plain numbers to all of a sudden you've got those silly letters in there. So understand that that means exactly the same thing. With segment addition, you're taking a smaller segment, adding it to another smaller segment, and when you add them together, you get a bigger segment. So we took our smaller segment, we added it to our other smaller segment, and we got our bigger segment. And now here it's just an algebra problem. Okay? So you're going to add your x and 3x, and it's going to be 4x plus 1 equals 25. You would minus your 1, so 4x equals 24, and then you divide by 4, and x equals 6. So the length from A to B would be 6 units. The length from B to C, you'd take 3 times 6, which is 18, plus 1 is 19. And you can double check by saying, well, is 6 plus 19 25? Yep, then I know I did it right. Okay. So that's how we are going to use segment addition in geometry. Some of them will be this easy where it's just numbers that you're looking for. But a lot of them will have the algebra in it, so be prepared for that. Okay, this one, same concept. We have NO is 25, OP is X, and NP is 41. So we're going to do smaller segment plus smaller segment equals bigger segment, and we will solve. So X is 16. Okay. Another way that we can use what we've learned in this chapter or in this section in particular, because now we can also use midpoint. If I know that the point is the point in the very middle of the segment, okay, here we didn't know that. We didn't know that B was in the middle, or we didn't know that O was in the middle. But if we are told that the point is in the very middle, then we can go back to that definition of midpoint that we talked about, and we know that this segment is congruent to this segment. In that case, in the case where we know that this point is in the middle, we can set up the problem a little bit differently, because we know that 5x plus 9 has to be equal to 8x minus 36. Because m is in the very middle, so I know that whatever this is, it has to be equal to whatever that is. And now I do my algebra that way, so I would minus my 5x's over and get 3x, and then I would add my 36 over to the 49 because it's being subtracted, so I'd add it, and I'd get 45, and then I'd divide by 3, and x is 15. Now that just tells me what x is. That does not tell me what the length of the segments are. So be careful in your problems. If it says find the length from M to R, then you have to take that 15 and plug it back in. So 5 times 15 is 75, plus 9 is 84. So the length from M to R is 84, and I should get exactly the same from M to T. If I plug in 15, 8 times 15, and then I minus 36, I better get 84 because M was the midpoint, which means that the two segments had to be equal to each other. Okay? So that's two different ways that we can use what we've learned about segments and measuring segments to find missing values. That concludes this lesson, and your homework for each of the classes is as follows.